Hey guys, Mr. Backberg here. In this video, we're going to look at the ambiguous case, which involves a triangle of the form side-side angle. Now, as we're taking a look at the ambiguous case for the law of sines, things get a little trickier. So what we're going to be given is side A, side B, and angle A. And depending on that information that we're given, there's going to be a lot of things that we need to check. The first thing that we're going to look at is if A is acute. And there's actually 4 different cases for if A is acute. And depending on which case we're dealing with, there could be no triangle that exists, there could be one triangle that exists, or there could actually be 2 triangles that exists. Now there's an h value in here which actually stands for the height of our triangle, and the way we calculate the height is by taking side B times the sine of angle A, and in a few of these cases for A being acute we're going to use that height to help us out. So if A is acute and side A is shorter than the height of the triangle, then no triangle exists because side A isn't long enough to complete this triangle in here. Now, if side A is equal to the height of the triangle, it actually forms a right triangle, and then one triangle is possible. If side A is greater than or equal to side B, then that's another case where we're only going to have one triangle. But if the length of side A is between the height and the length of side B, then things get really tricky, and we actually have 2 triangles that could be formed. A could be the side from an obtuse angle, like we see over here on the left-hand side of our picture, but A could also be the length of a side from an acute triangle, like we see in our larger triangle there. Now, if A is an obtuse angle, then we've only got 2 cases to check. If A is less than or equal to B, then no triangle exists because side A isn't long enough to complete that triangle. But if side A is bigger than side B, then there's one triangle that exists. So as we take a look at this first example, we're going to solve the triangle given that side A is 7, side B is 6, and angle A is 26.3 degrees. Now the first thing we want to figure out is how many triangles there are actually going to be. So the first thing we look at is our angle, and A is an acute angle. And then I want to look at the sides that we're given. So we're given side A as 7 and side B as 6. So we can see that side A is greater than or equal to side B, meaning that this is a one triangle case. So based on the information that we have available to us, the first thing I want to find is angle B. And since I want to find an angle, then I'm going to use the form of the law of sines where I have the sine of angle B on the top of this fraction. Now on the bottom should be side B, which is 6. Because I put an angle on top, I need to put an angle on top of the other side. So this is going to be the sine of angle A, which is 26.3 degrees, divided by side A, which is 7. Now I'm going to multiply this 6 over to the other side. So if I rewrite my fraction, I'm going to have the sine of angle B equals 6 times the sine of 26.3 degrees divided by 7. But this doesn't actually solve to get B alone. I would have to move that sine over to the other side. And to move a trig function over to the other side, we need to do the inverse trig function. So we need to do the inverse sine of this 6 times the sine of 26.3 degrees, all being divided by 7. Now I'm going to type this into my calculator, and when I do so, I need to be careful because we need to make sure that we're in degree mode. Now I'm just going to go to 1 decimal place here, so we should get B to be about 22.3 degrees. Now that we know 2 of our angles, it should be easier for us to find the measure of that third angle because, again, the angles inside of a triangle have to add up to 180. So if we take 180, subtract off the 26.3, and subtract off the 22.3, then we should get angle C to be about 131.4 degrees. Now the last thing we need to find is side C. So I'm going to take side C over the sine of this 131.4 degree angle equals, now in my initial setup I was given information about side A and angle A, so I'm going to use that to help me out. So I'm going to go 7 divided by the sine of 26.3. Now I need to multiply that sine of 131.4 over to the other side. So if I rewrite my fraction, I'm going to get C equals 7 times the sine of 131.4 divided by the sine of 26.3. And I should be able to type all of that into my calculator again. I'm going to go to 2 decimals for this side. We should get about 11.85. So now we found all of the missing information. We said that angle B was going to be 22.3 degrees. We found angle C to be 131.4 degrees, and then we found side C to be 11.85. So that was all of our missing information. Now we're going to take a look at another example in here, and we're given that side A is 6, side B is 7, and angle A is 30 degrees. Again, the first thing we want to check is how many triangles can be formed. Angle A is an acute triangle, so we need to check our cases for acute triangles. There is no specific case that just says A is smaller than B, but what we need to do is we need to find the height of our triangle. So remember, to find the height, we take side B, which is 7, times the sine of angle A, which is 30. So 7 times the sine of 30 ends up being 3.5. And there is a case where side A is between the lengths of the height and side B, and that's actually our 2 triangle case. So I'm going to separate out these cases in here by just putting a line down the middle of our screen. On the left-hand side, we're going to do case 1. And once we're finished with that, on the right-hand side, we'll take care of case 2. Now, based on the information that we have given to us, the first thing I want to find is angle B. So I would do the sine of angle B divided by the length of side B equals sine of angle A, which is 30, divided by the length of side A, which is 6. Now I'm going to multiply that 7 over to the other side. So when we do that, we're going to get the sine of angle B equals 7 times the sine of 30 divided by 6. But again, I need to do the inverse so that I can solve for angle B. So then B is going to equal the inverse sine of 7 times the sine of 30, all being divided by 6. And I'm going to type this into my calculator and go to 1 decimal place here. So we get angle B to be about 35.7 degrees. Now from there, we should be able to find the measure of angle C by doing 180 minus that 30 minus that 35.7. And we should get 114.3 degrees there. Now we still need to find side C, so I would do C over the sine of this 114.3 equals 6 over the sine of angle A, which is 30. I need to multiply that sine over to the other side, so I'm going to get C equals 6 times the sine of 114.3 divided by the sine of 30. And when I type that into my calculator, going to 2 decimals, we get about 10.94. So there's our missing information for case 1. We got angle B to be 35.7 degrees. We got angle C to be 114.3 degrees. And we got side C to be 10.94. Now we said there was going to be 2 triangles. To start with handling case 2, we're actually going to look at where we calculated angle B. What's happening in here is that in this first case, we're going to assume that angle B is an acute angle, which is why we use the 35.7 that our calculator gave us. But there's also another answer that happens in here when we do the inverse sine. But our calculator can only give us one answer, and it'll only ever give us the acute angle answer. But angle B could actually be an obtuse angle instead. So if we want to calculate the obtuse version of angle B, then what we would do is take 180 degrees and subtract away that answer that we got earlier, so that 35.7. Now when we do that, we get angle B to be about 144.3 degrees. Now based on having a new calculation for angle B, that's going to give us a new measure for angle C as well. So if we take 180 degrees minus our 30 that we were given for angle A, and minus that 144.3 that we just found for our obtuse angle B, then what we end up getting is about 5.7 degrees for angle C. And since we got a new angle C, now that's going to give us a new side C. So I'm going to do C divided by the sine of that 5.7 degree angle equals the 6 over the sine of 30. I'm going to multiply that sine of 5.7 over to the right-hand side. So we get C equals 6 times the sine of 5.7 divided by the sine of 30. And I'm going to type this into my calculator. And we should get about 1.19 as side C. In this example, this is going to be a no solutions case, so we want to show that there is no possible triangle given that side A is 15, side B is 25, and angle A is 85. So the first thing we would want to do is check how many triangles can be created. So we look at our angle, and A is acute. Then we look at our sides There's no specific case that says A is smaller than B. We need to calculate the height. So to find the height of our triangle, we would do 25 times the sine of our 85-degree angle. And when we do that, we're going to get about 24.9. So because side A is smaller than the height, then that means that no triangle is possible. That's going to be it for this video. Thanks for watching.